Welcome to Healthcare AI Weekly. I'm Raphael Malikian, and this is the show where we turn new healthcare artificial intelligence papers into practical, clinically grounded takeaways for people building, buying, researching, or governing medical AI. If you want a weekly filter on what matters, beyond hype and beyond press releases, like this video, subscribe, and send it to one colleague who has to make decisions about clinical AI this year. Two new healthcare artificial intelligence papers point to the same uncomfortable truth. The future of clinical AI is not just about smarter models. It is about whether those models can survive messy language, messy workflows, and messy hospitals. Today we are looking at one major paper on large language models reasoning through epilepsy narratives, and one easy-to-miss paper on nurse concern signals for inpatient deterioration. If you are a clinician, hospital leader, developer, or medical researcher, these papers are not trivia. They touch diagnosis, safety, staffing, escalation, documentation, and the question every AI product eventually faces: can this help in the real world without creating a new risk surface? The major paper of the week is titled Evaluating Large Language Models for Diagnostic Reasoning from Unstructured Clinical Narratives in Epilepsy, published in Communications Medicine. The authors ask a practical question: can large language models, or LLMs, interpret unstructured clinical narratives in epilepsy? Unstructured simply means the text is not a clean spreadsheet field. It is the kind of real clinical language that appears in notes, referrals, patient descriptions, and history-taking. In epilepsy, the words used to describe a seizure can carry diagnostic clues about where in the brain the seizure may have started. The study tested 8 models, including general models such as GPT-3.5 and GPT-4, and medical models including OpenBio LLM and Med42. The task was to map seizure description phrases to one of 7 possible seizure onset zones. Think of this as asking the model to read a clinical clue and place a pin on the most likely brain region. The authors measured correctness, confidence, calibration, reasoning quality, and citation accuracy. Calibration means whether the model's confidence matches reality. If it says it is 90% sure, is it actually right about 9 times out of 10? The headline result is that most models performed well above chance after prompt engineering, and some results approached clinician-level performance. Prompt engineering means changing the instructions and context given to the model, rather than retraining the model itself. The strongest gains came from clinician-guided chain-of-thought reasoning. In plain English, that means asking the model to reason more like a clinician would, step by step, instead of blurting out an answer. Performance was strongly affected by 3 things: clinical role framing, narrative length, and language context, with reported performance variation of 13.7%, 32.7%, and 14.2% respectively. Quick pause. If this kind of translation is useful, taking a dense paper and turning it into the questions you would ask in a clinical AI meeting, tap like and subscribe. It tells me to keep making this weekly, and it helps other healthcare AI stakeholders find the show. But here is the part that should make every healthcare AI stakeholder sit forward. Expert review found that correct predictions could still be supported by hallucinated knowledge or inaccurate citations. Hallucination means the model generates something that sounds plausible but is not grounded in the source evidence. So the model may land on the right answer while taking the wrong reasoning path. In clinical AI, being right for the wrong reason is not a harmless party trick. It is a governance problem, a liability problem, and eventually a patient safety problem. The MIST paper is enhancing prediction of inpatient deterioration by combining clinical and nurse concern features, with or without temporal clustering, published in JAMIA Open. It may not trend like a large language model paper, but it might be closer to hospital reality. This paper studies early warning systems, or EWSs, which are tools designed to identify hospitalized patients who may deteriorate before a crisis, such as cardiac arrest or death. Traditional systems often rely on vital signs and clinical measurements. This paper asks, what if the model also listened to nursing concern? The authors evaluated a framework called HPM Expert Signals, which uses patterns in nursing documentation as signals of concern. For example, frequent checks can be a proxy for a nurse thinking, something is not right here. The models were trained to predict deterioration 12 hours before cardiac arrest or death. The main metric was F-measure, which combines precision and recall. Precision asks, when the model raises an alarm, how often is it meaningful? Recall asks, how many true deteriorations did it catch? The combined model using both clinical features and nursing concern features reached an F-measure of 0.25. Clinical features alone reached 0.16, and HPM expert signals alone reached 0.19. Before we get to the takeaway, comment with your reaction. Should hospitals be using documentation patterns as predictive signals, or does that risk turning normal nursing workflow into surveillance? I'm especially interested in views from nurses, informaticists, hospitalists, and patient safety teams. This paper's hidden value is that it treats healthcare AI as a socio-technical system. That means the technology is inseparable from the people, processes, incentives, and documentation habits around it. A nurse checking a patient more often is not just noise in the record. It may be encoded clinical intuition. For hospital executives, this matters because the best predictive model may not be the one with the fanciest architecture. It may be the one that respects how care teams already detect risk. The caveat is generalizability. Nursing documentation patterns may differ across hospitals, units, staffing ratios, electronic health record templates, and cultures of escalation. A signal that means concern in one hospital may mean routine workflow in another. Taken together, the two papers give us a useful framework. The epilepsy paper says, language models can reason impressively, but their reasoning must be audited. The nurse concern paper says, hospital AI can improve when it includes human workflow signals, but those signals must be validated locally. My takeaway, the next wave of healthcare AI will not be won by benchmark scores alone. It will be won by systems that are interpretable, workflow-aware, locally validated, and humble about uncertainty. If you are building or buying healthcare AI, ask 3 questions. What real clinical signal is this using? How was it validated outside the development setting? And what happens when the model is right for the wrong reason? If this helped, like the video, subscribe to Healthcare AI Weekly, and comment with the kind of paper you want next: diagnostics, operations, patient safety, mental health, or AI governance.